Hey everyone, I wanted to make a short video to talk to you about joining data together. As you've started looking at the data for your projects for our course, you've noticed that the data that you have access to isn't all neatly inside of one table. It's spread across multiple tables for the vast majority of you. This is really common, actually. It's good database design to have data split across tables. I'm going to talk to you just about two different ways to put data together that cover all of the bases that any of you will need for your projects. But know that there are other types of joins that you can do. We're going to talk about the first thing I'm going to show you is not actually a join. It's just concatenating two tables together when the set of columns match. So it's like I have an old version of my data and then some new data that's come in recently with overlap. So my columns match. I just want to take the two tables, put them together as one, stacking the rows one on top of the other. And the second type of join that I'll talk to you about is truly a join. It's when I want to take columns from one table that contain information about observations um, and attach them to another table by looking at a matching column. The way we're going to do that is with something like join. So let's take a look at the data that I have. I set up a uh, fake data set that we can work with and kind of talk through some examples. So the first case, like I said, we have two tables. Those two tables contain the same column names. They contain disjoint data. Uh, and I would just like to stack the tables one on top of the other to get all of my data together in one place. There are a couple of things that we need to worry about with this. One is that they do need to have exactly the same column names, spelled the same way, and in the same order. And then the second thing to worry about is I need to make sure that there's no overlap in the actual data that I'm trying to stack here. So that means that if I look at data frame one, these rows are not also present in data frame two, because otherwise I'd be duplicating information, which we don't want to do. We want each row to be present exactly one time in the data set that we ultimately use for the analysis. We don't have to worry about either of those things here, but again, that's something that you will potentially want to look out for when you're working with data in the real world. So I have two data frames here. I have data frame one, which has 10 rows and 3 columns. It has a transaction ID column, a product ID column, and a quantity column. Then I have a second data frame called DF2. It has 40 rows and it has 3 columns. It has the same 3 columns as DF1 has. Really, all I want to do is I want to stack these two data frames one on top of the other so I have a single data frame with 50 rows and these same 3 columns. So here's what we'll do. We're going to give this new data frame a name. Let's call it transactions DF. To stack the data frames together, I'll use some pandas functionality. Pandas has functionality called concat or concatenate. This pd.concat function will take a list of data frames. So remember, lists are defined using square brackets. I'm going to type in here df1 and df2 because those are the only data frames I have. But if you had more data frames, you could just continue listing them here, df3, whatever your data frames are named. When I do that, I'm going to get the two data frames stacked one on top of the other. We can print out the shape of the data frame, so transactions df.shape. This will again show us the number of rows and the number of columns in my data frame. If all of this works well, we should end up with 50 rows, right? The 10 from df1 and the 40 from df2, and still 3 columns. I'm not doing any operation here that should change the number of columns I have. So let's then also print out transactions df so that we can see the data that we end up with. We're going to want to make one change after seeing that. So you can see that this worked largely the way we would expect. We have one large table with 50 rows and 3 columns. Excuse me. The three columns are the same columns as we expected. They're the columns from DF1 and DF2. One thing that we may not have expected is this index column starts from 0, counts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but then starts back again at 0 when I start adding on the rows from data frame 2. There's Python uses the index column to kind of track operations on a data frame. And so having an index that does this repeating or exhibits this repeating phenomenon is potentially problematic. So one thing we may want to do is say, down here, let's look at transactions data frame. Let's use reset index. So I'm going to overwrite the transactions data frame. I'm going to reset the index. And I think there's an argument here called drop, and it defaults to false, but I'm going to change that to true. Usually what happens when we reset the index is this index column becomes inherited by the data frame as a new column, and I don't want that to happen. Let's then print out transactions df. We'll just do the header this time to see what the data frame looks like. Perfect. So now we have a new data frame with 50 rows and 3 columns. We still have the same columns as the original 2 data frames had. The index starts at 0. I guess I didn't show you enough of this, so let's print out the entire data frame to show that the index doesn't do that restart anymore. Yeah, here you can see the index count starts at 0, goes up to 9, and doesn't restart anymore. So these are truly the row numbers. And so that's stacking 2 data frames together. So again, if you have 2 data frames that contain kind of the same information, the same column information, but for different observations, and you just want to stack those data frames together, you can use pd.concat to concatenate or stack those data frames. You will end up in a scenario, though, where your index is a little bit messed up. And so you can use this reset index functionality with a drop equals true argument to reset the index so that it starts counting from with rows from 0, doesn't do a restart, and you don't inherit the old index as a column in your result. All right, so let's take a look now at another scenario where we'll use actually this transactions data frame that we just constructed as part of our objective. Let's say now we have multiple tables, but those tables have different columns. They contain different information from one another. So the transactions DF data frame has transaction ID, product ID, and quantity, but maybe I have another data frame that contains the products and their prices. And I'm interested in trying to compute the value of a transaction. For that, I would need the price of the product and the quantity so that then I could multiply price times quantity to get a value. So to get those 2 pieces of information in the same table, we'll need to join the price information onto the transactions data frame. So here's my price table. You can see it contains just 2 columns, the product ID and the corresponding price. I'm going to print back out for us transactions df, and we'll print out just the header of it so we can see the 2 tables at the same time. What I'd really like to do is I'd like to take the information from the prices data frame and attach it to the transactions data frame. We can't just stack the columns next to one another like we did earlier with rows, because product A has a particular price, and I want that price to go along with rows that belong to product A. Product D has a different price, and I want that price to be matched with any row where the product being identified as product D. We'll do this with a join. And the type of join we're going to use is called a left join. So what that means is we're going to start with a table that we want to build off of. And that table will be on the left. So transactions, df. And then what we're going to do in Python is called a merge. In other softwares, maybe you've used SQL, these are called joins. They work the same way. So the data frame that I want to merge with transactions df is prices df. Merge has an argument here called how, and this is going to determine how the join is done. We're going to use a left join, which just means I'm starting with the transactions data frame, and I want to add new columns onto that data frame. Sorry for writing low here, I really meant left. So the transactions data frame is on the left. This is the data frame that I'm starting with, and I'm potentially adding new information onto it. Then I need to define the columns that I'm making a match on. Here, I'm lucky because my two data frames have a column name that matches. So I can just define on, and I'm going to provide the column name. So I'm matching on product ID. I'm going to look at the product ID in the transactions data frame table, and then I'm going to look for a match in the prices data frame. And then I'll attach the information from the prices data frame to that corresponding row in the table. So in the first row here, I should be able to attach a price of 3. In the second row, I'll look for a match. I'll find that the price is 11. I'll attach a price of 11 there. Let's just see if this works as we expect. Perfect. So now we have a new data frame, which has all of the old columns, transaction ID, product ID, quantity, and now the new column that I wanted to bring in, which was price. Once we have this, so I didn't store this data frame, we can, maybe we call this orders df, and we can look at orders df.head. So now orders df contains all of the information about the transaction, including the product, the quantity of the product that was purchased, and the price of the product. We could now, if we wanted, create a new column in orders df, value, which we could calculate using the quantity column multiplied by orders df times price column, and then look at orders df.head here. And so now all of that information is contained in one table, and we can use it moving forward. So this video, I'd like to close it here, has shown you two things. One, how to stack two data frames together if they contain the same column names and different row information. You just want to combine the existing tables into one large table. And then secondly, how to join information from two or more tables together using the merge functionality from pandas. I hope this is enough to get you started. Reach out to me if you have any questions at all. Good luck as you're starting to work with your projects. Thanks, everybody.